Hi guys, it is day 5 of Unit 5, and we have another day talking about mean proportional. So the reason we have a second day is because there's a second relationship that becomes really important here. So I'm actually going to backtrack to page 12 for just a moment. So you can look back at your own page 12 or just look with me from the notes. This is from yesterday's notes, and it was the idea of showing that when you have that right triangle and the altitude drawn, that you get those 3 similar triangles. Yesterday, we focused on the 2 triangles, the 2 little guys being similar, and that's where our rule about the altitude being the mean proportional came from. Today, what we're going to look at, if you kind of look here, is we're going to use the small little triangle and the big triangle. And we're going to use both of the smaller triangles with the big one, but one thing at a time. So when I come back to this page, I'm going to look at the small triangle, this one on the left here, and then the larger triangle, this one here. So if I look at just the letters, it's ADC. So I'm going to kind of come down here. Whoops. See if I can get myself some space here. There we go. So I'm going to re-sketch what's going on there. It doesn't have to be gorgeous. It'll get the point across. So A, D, here's C, here's B. So it was triangle A, D, C, being similar to triangle A, C, B. All right, just how we did in yesterday's notes, I want to focus on specific pieces here. So I want to look at side AD and then AC. All right, so that means this one and then the first and the last. Okay, so I'm going to say AD is to AC. So I have to make sure that I use the same parts of the bigger triangle. So that's the first 2 letters, AC, and then the first and the last, AB. All right, well, what we start seeing presenting itself here is that AD is to AC as AC is to AB. So here's that same segment being the mean proportional between the other 2. All right, well, if I look in the picture, AC and then AB is this big old guy here. So one way we can kind of look at it is to actually say like, all right, in this little triangle, AD is a leg and AC is the hypotenuse. So in both triangles, whoops, you're looking at the leg here to the hypotenuse here. And now refocus your eyes on the big triangle. AC is the leg, AB is the hypotenuse there. Right? So there's a couple ways you can look at it, but either way, it's the idea that the leg becomes the mean proportional between these other 2 little pieces here. All right. So now when I flip back over to page 15, you can see that those are the parts that are marked. What the rule is, if I can think, leg to hypotenuse. So I'm kind of, maybe I won't abbreviate there. Hypotenuse, there we are. Then in the small triangle, the leg is the A part of it. The hypotenuse would be the X. And now in the big triangle, so big triangle now, that's this guy. X is the leg. And then the hypotenuse is this whole length here, C. All right. And so we can cross multiply and then be able to solve for that X value or any value in that relationship that we want, right? But it's all based on the setup as the leg is the hypotenuse equals the leg to the hypotenuse. All right, so with these ones, there's a key step you need to make sure that you do first. I'm going to slide on up here so you can see this first example, right? So if I look, I've got the small triangle on the left, just like the picture above. So it makes it kind of nice and easy to look at this one. So 2 would be the leg. So it would be 2, and then is 2, the hypotenuse of X. All right, now look at the big triangle. When I look at the big triangle, the leg here is the X piece of it. So we're repeating that. And then is 2, the whole hypotenuse. So I can't just use 2. I can't just use 6. I got to put all of that together. So 2 plus 6, I'm going to get 8 there. So sometimes I will find that people will do better with this if they actually like circle the parts they need. So like 2 is to x, and then as x is to 8. From there, we've done this solving. You know how to do this. Cross multiply. So x squared and then equals 16. Technically, it's plus or minus 4 when you take the square root, but we don't need the negative 4 because it's a side length. So just x equals 4 would be our answer. And that's it. All right, so we can use those proportional parts, just like we did yesterday, to solve for any missing lengths of the triangle. Now, the only difference when you look at this next one is where the leg is. So here we were using this leg on the left. Here, the leg that's labeled is the leg on the right. So when I kind of draw out my triangles, I'm going to highlight the little triangle on the right-hand side this time. So if I think again about the leg to the hypotenuse in my blue triangle, the leg is any of the two sides that are perpendicular to each other. So that's the 5 here. And then the hypotenuse is the x. So I'm going to go 5 is to x. And then as, now free focus your eyes. Look at the big triangle. In the big triangle, x is now the leg. So as x is to, this whole thing is the hypotenuse of that big right triangle. So 3 plus 5, we get 8. And that's our setup. So it's the leg is to the hypotenuse, as the leg is to the hypotenuse like that. All right, when you cross multiply, we get x squared. We get 40. And then when you go to take the square root, if it's not a perfect square, we got to think, what's the biggest perfect square that goes nicely into 40? That's going to be 4. And then times my leftover of 10. The square root of 4 is 2, so that radical hat comes off. And then we're left with the radical 10 there. That should be our answer for this guy here. Right? So you have to just think a little bit about, am I using the relationship on the left or the relationship on the right, depending on which parts you're going to plug into the proportion. Right? So if it helps, you can come back up here and you could kind of draw that same picture again. And all you'd have to change is which leg is being labeled. So if the X is over here, then the A, the piece I'd want to plug in, would be over here. And this would be C. And then that still is going to match. So this is still going to be the proportional sides that you'd end up with. All right. But I think sometimes it just helps to have that visual. But keep in mind, we can rotate this picture all over the place. So you might need to flip back. That's perfectly fine. And when I say we might, rotate it, is you might see the picture in a different orientation. Now on the next page here, on page 16, it looks pretty similar to what we just had. Just pay attention as to where is the leg. So if the leg is over here on the left, then when I say to set up the first part of it, I need the piece that's adjacent to it or that is next to it. So I'm going to say X is to 6. And then as 6, I'm going to repeat this, is to the whole hypotenuse. So that's going to be X plus 5 right here. If we keep going, cross multiply, we get X times X plus 5, and then equals 36. We've seen some like this. We can distribute. So X squared plus 5X, and then move it on over. Now that we have it equal to 0, our goal is to factor. So we can look for what adds to 5 and multiplies to 36. Hopefully in your heads right now, you're already thinking of it, but X and X, and we can go 9 times 4. So positive 9, negative 4. And then I'm sometimes lazy about showing this step, but please remember, you're technically setting those equal to 0 to solve. So this one, you end up with negative 9. Here you would add over 4, so we end up with positive 4. So we can reject that negative 9, and X equals 4 would be our solution there. For number 4, see if you can set it up. Maybe even pause the video and see if you can figure out like what goes where. When you're ready, now we can try it. So if this triangle is the one I want to look at because this is the leg that's got the label on it, then I need to use the piece that's adjacent to that. So I'm going to use the x down here. So it's going to be x is to radical 15 as radical 15 is to this whole length down here. Right? And so because I'm going to use that whole triangle, and that would be x plus 2 at the bottom. And you can write it as x plus 2 or 2 plus x. That doesn't make a difference. What matters is that the part that goes here is the x because it's the piece that's next to radical 15 and in the same triangle with it. The 2 doesn't get used because it's not in the same triangle with that little radical 15. Okay? So now cross multiply. Here we get x times x plus 2. Here we get radical 15 times radical 15, which means radical 15 squared. Well, when you square a square root, radical sign just comes off, and all you end up with is 15. This we can distribute. And then just like last time, let's get it equal to 0 and factor it. So x squared plus 2x minus 15 will equal 0. And then we can say what adds to 2 multiplies to 15. That's going to be 5 and 3. So positive 5 and negative 3, so that this will add up to a positive 2. And then because I'm almost out of space, I know that when I set it equal to 0, it's going to flip signs when we solve. So this will end up a positive 3. That's a negative 5. We ditch the negative answer because that can't be a negative length right there. So x equals 3 should be our final answer right there. Right? I'm thinking number 5. Let's save this guy for class to do together. And then let's take a quick peek and see if there's anything else we want to do right now. On this last page, let's maybe take a look at one question together here. So with this, I'm going to slide on down. Number 7, it says in inches, the segments formed by the altitude on the hypotenuse of a right triangle measure 8 and 10. Ooh, that's a little tricky the way that that's worded. So it's saying you have a right triangle. You can draw the right triangle any way you want. So if you like that same orientation, feel free. I'm actually going to specifically draw mine a little different just so that we don't get married to that idea that it always has to look the way it did on that first page. So if here's my right triangle, they're saying that you have an altitude drawn to the hypotenuse. So an altitude drawn. So you're going to draw a perpendicular. This is the altitude. And it's saying the segments formed by the altitude of the right triangle measure 8 and 10. So I would say, based on my picture, I'll make the shorter one 8, the slightly longer one 10. It says find the measure of the shorter leg of triangle ABC. Well, if you can't tell from your diagram, then you could solve for both legs and then just whichever one's shorter. Otherwise, based on my drawing, this one looks to be the shorter leg of ABC. Oops, I forgot to actually label it. Oh, I guess it doesn't really matter. So I'm not even going to bother labeling it. I'm just going to call this one X. So I'm going to say X is my shorter leg here. All right. Look at how you have this. This little triangle is the one that's attached to the X. So I'm going to start with the 8. It's the little leg is the hypotenuse of that triangle. And then now I can look at the big triangle as here's the leg. So I'm going to use the X is to the whole hypotenuse. So 18 would be that whole hypotenuse there. All right, let's give it a try. X squared will equal 8 times 18. Let me grab my calculator here. 8 times 18, that'll give me 144. And then we can take the square root and we get 12. Now, if you trust that you did it correctly, if you want to be certain that that's the correct answer, we can either solve for this part here by setting up a proportion, or you could actually choose to use something that we're going to talk about in our next unit, but I think you've seen before, and that is the Pythagorean theorem. Actually, I know we've done it before because we talked about it in Unit 4. If I look at that big picture now, this is 12. That whole length is 18. we can go ahead and answer for this part just to double check and make sure that this 12 is shorter than whatever that is. So in that regard, whew, now we're going to something totally different. We'd be A, B, and C, and we'd be plugging in here to check it on out. So if we do 12 squared plus, oops, I guess I should have put X there. Sorry about that. Don't want to confuse you. Let me put that here, and then plus 12 squared equals 18 squared. It doesn't matter. I just didn't want to confuse anybody. We'd get X squared plus 144. 18 squared, 324. All right. So 324 minus 144, we get X squared equals 180. And then when you go to take the square root of that, that comes out as 13.4 and so on. Now, even though we would normally leave the answer in simplest radical form, what I really care about is which one's the shorter leg. Well, if this leg comes out to be like 13.4 and change, then the 12, we were correct with our diagram that 12 is the shortest leg of triangle ABC. All right, that's it. Number 6, we'll take a look at in class. Otherwise, make sure that you've answered those questions and you should be good to go. Thanks, guys.